Osvaldo.
Hello,
Uh,
how are you?
I'm fine, thanks. Let's pretend that we were not backstage talking to each other for the last 10 minutes.
Cool.
Hello and welcome everyone to yet another episode of Expert Insights Live. If you can hear us, it would be great if you can just pop up a comment and tell us that you can hear us. Do tell us where you're watching us from today. It would be good to know that there are people watching us and it's not just Osvaldo and I talking to each other, just like we were doing 10 minutes ago. So, yeah, please do let us know and then we can get started. Uh, in the meantime, Osvaldo, if you can just introduce yourself, who you are, and what do you do, that would be great.
Yes, I'm Osvaldo Martin. I'm a researcher at CONICET. This is a national institute or institution actually in Argentina for scientific and technical knowledge. I'm also an open source developer. Um, I help or contribute code to different software like PyMC, ArviZ, and more recently other software like Bambi, Predly, Schoolprint, PyMC Bar, and essentially all software that is related to Bayesian statistics and analysis of Bayesian models.
Perfect. Uh, okay, so I'm still waiting for comments for people to confirm if they can hear us. I can see a few comments for the raffle, but okay, let's hope that people can hear us. And with that assumption, I think we can move ahead. There are people. Okay, so there is a comment
Okay,
from Imtiaz Lawrence from South Africa.
nice.
Welcome, Imtiaz. And I can also see there are quite a few people who've read the ticker at the bottom. There is a ticker at the bottom which says that there are a couple of giveaways. So there's Karthik Sharma on YouTube. There is Darnell Moore on YouTube. And, well, they're rightly commenting hashtag pack. So if you want to win an e-copy of Osvaldo's latest book, Bayesian Analysis with Python, third edition, please feel free to comment. Uh, Hi, Pat on YouTube. And Darnell is confirming that everything sounds great. Didn't want to disturb. Thank you so much, Darnell. That's really kind of you. Uh, and this is a show for all of you. None of you would be disturbing us. Please feel free to pop in any queries that you have for Osvaldo. We will take it live during the session. Uh, in the meantime, Osvaldo, let's start with a few queries that I have. Uh,
Mhm.
so let's start with base or not base? I think that's one of the questions that a lot of people ask. So, if base, why base? Can you please answer that?
Um, yeah, well, there are different takes. Uh, there are people that are like very Bayesian, they're more Bayesian than Bayes, that they are going to answer that you have to do Bayes because it's the um, right way to do things. I prefer a more practical approach.
Hmm.
And basically, I use Bayesian statistics because I found it useful. Actually, that's the way I arrive at Bayesian statistics, is because I have a problem from my domain. I used to work with protein models and other biomolecular models. And I need to do stuff that I was not able to do it otherwise. So I start searching and I say, okay, somebody have to already think about how to do these kind of things because it's, I don't know, it's something that it's should be common. And then I found this Bayesian statistic and I say, oh, okay, this is what I really need for my problem. So that's the way I started, something like I need for my problem. And then the other thing that convinced me of using Bayesian statistics is that for me, I previously to that point, I have tried to understand statistics for many years. And every time I tried, I failed. I tried and I failed. I tried and failed. I tried and failed. Even I have a course at university. Actually, I passed the course with good grades, but even then, I was not sure what I was doing. I have these 4-hour exams, just doing a lot of math with pen and paper and some calculator. And at the end of the exam, I have no idea what I have been doing for the whole time. And that was kind of my experience with statistics. And when I started learning about Bayesian statistics, I realized that it's a common framework to think about problems. And that really appeals to me. that I now, maybe I don't know the solution, maybe I don't know what to do, but I have a framework that can help me think about my problem, about possible solutions, and that's something that for me is very, very appealing. Also, there are some people that are going to tell you about this uncertainty that is when you are doing Bayesian statistics, you are dealing with uncertainty in a formal way, and that's true. But I think there are also ways to deal with uncertainty using other frameworks. So still, for me, the most appealing point of Bayesian statistics is that you can think about your problem.
So we are still waiting for questions to come in from our viewers. So if you have any questions, please plop them into the chat. And don't worry, you're not disturbing us. This is a live session for all of you, and we'll be more than happy to get Osvaldo to answer questions for you. So Osvaldo, while we are waiting, I have quite a lot of questions to ask you, and I can keep on going with them. So how does one appropriately specify a Bayesian model for their specific problem? And what considerations should they keep in mind?
Well, that's a big one and a difficult one, actually. No, the reason is that I say Bayesian. I think the reason is that first, Bayesian statistics is about a framework to reason about problems. So in that sense, it's super broad. So you can use it to think about a simple model that has, I don't know, 3 or I don't know, a couple of parameters, or you can use it to think about a super complex model like a neural network that has gazillion of parameters, and the framework is the same, but the models and the problems and your interests are completely different. So it has a lot of flexibility, and sometimes having a lot of flexibility can see as a burden because you need to take some decisions. And that's something that Bayesian statistics actually kind of force you to take decisions and be accountable of those decisions. And the other thing is that you usually use modern Bayesian statistics is about computers. Yes, it's computational statistics. So we do Bayesian statistics using software like PyMC or Turing or Stan or that kind of PPLs. And this software is also built to try to take advantage of this framework that is super general. So because the approach is very general, it's difficult to provide something very specific and say, you have to do this and this, okay? But of course, there are some things that you can use as a guide. And actually, in the last few years, people have been starting to think a lot of best ways to approach Bayesian statistics. There was, for example, now the term that is more common, that is this idea of the Bayesian workflow that Gelman, Aki Vetteri, and others wrote a paper about that. And they try in that paper to answer your question. It's like a 60-page paper. Maybe we can then provide some notes and link it there. But it's basically, the name is the Bayesian workflow or Bayesian workflow, something like that. It's an archive. And they take these so many pages to explain because there are different aspects. So one aspect is about what are you going to do with your priors. Another aspect is what are you going to do with your, because usually you need to sample from this model using MCMC methods. So it's not something that you can compute. The interesting models is something that you cannot compute with pen and paper. So there are like many aspects. One general idea I think that you can use when trying to formulate models is try to think about your problem. Try to think about what do you want to get, what are the answers to your problem, but also try to think this idea of the data generating mechanism. So how do you think the data could have been created? No? For some people, this is more easy. For instance, if you came from something like physics or biology, maybe you already have an idea because if you came from physics, you have a theory that says, okay, I don't know, supernova generated in this way, or the spot on the suns are due to this process. So you have an idea behind. And the same for biology. Maybe you know, okay, cells interact in this way. So you have this notion. But even if you don't, even if you are working in industry and the only thing that you care is how to increase sales, it's a good idea to think about how how the sales are done. Okay? And generally that provides tips and things that you can go and try implement in your model, and then you can iterate and say, okay, if I try this, actually my model improve, I get better predictions, I have a model that is cleaner. So there is not a single answer to this, but I think this thinking about this Bayesian workflow in general, and thinking about this, how the data was generated, and having this modeling mindset can help. And that's also a big difference to other approaches that you generally, you say, okay, I want to fit this data, so I try many methods and I see which one generate the better predictions, or something like that. Here in Bayesian statistics, usually you gain more if you actually try to think a little bit more about your problem and the answers that you want to get.
Perfect. Thanks a lot, Osvaldo. That was quite a big question, and thank you so much for taking the time to answer it. I see that in the comments, someone on YouTube mentioned that they would be interested in the paper. I've Googled it, and I've shared the link of the paper with them. In case anyone else is interested, if you're watching it on YouTube, I've shared it. If you're watching it on LinkedIn, there is someone named Ronald who has kindly shared the same link to that paper. And in case you're watching it on my personal YouTube, which is a rare likely, it's just me and my wife who watch it there. Then yeah, again, there is the link over there, so you can find it there. Oh yeah, great. They've got the link to it. Great. There is a question from them. Uh, I don't know what their name is exactly. Look at this 6 on YouTube says, can Osvaldo talk more about using Bayesian analysis in industry, like marketing, for example, getting buy-in, resources specific to that, and outside the PyMC examples, etc.
Okay. Again, industry is not my main domain. Actually, just recently I started working with PyMC Labs, that is a consultancy company, and they do a lot of work in industry. So I'm getting familiar with the models that they usually use there, like these marketing models. but in generally, again, I think that there is not too much difference between the models that people use in physics or people use in industry, in the sense that both models are, again, you get the more from the model if you think about how the data could have been generated, and you try to think more with this modeling mindset, let's say. So don't try to approach problems as this, okay, I'm going to take, I don't know, this model that is going to take from a shelf, and I'm going to just plug it my data. Because of course that can work, and usually maybe that's all you need. But usually if you really want to get some advantage, usually that's only the first step. So only when you have that kind of model and say, okay, this model generates something that is reasonable, you can start iterating and try to do things like these posterior predictive checks. This is basic, has a very complex name, but basically is generating prediction from your model and comparing the predictions of your model to your data. We discuss a lot that in the book. Actually, again, the idea is super simple, but it's super powerful, because that can lead you to improvement. So you take this, your model, whatever model you have, you generate prediction from the model, and you compare with the data. And the idea is that not to check that you are able to fit the data, because of course you should be able, unless you make some gross mistake, because essentially you're comparing to the data that you fit. Okay, so the model should be able to recover the data. But the interesting thing is that usually they are going to be mismatched. Okay, so maybe I don't know. It's typical you can recover the mean of the data, but you are not very good at recovering the tails of the distribution. So that's signaling that it's something missing in your model. That kind of approach, and that can provide you input so you can iterate and go back to your model and say, okay, why am I missing the tails, or why am I missing this particular aspect of the data? So sorry that again I don't have a very specific answer.
Osvaldo, in the book, you have quite a lot of real world examples. So if that could probably, if people could cross learn from that. So what are the real world examples that you use in the book then?
I have data sets for chemical shifts. That is something that I used to work. It's something that you obtain from NMR experiment, nuclear magnetic resonance. I have some, I added now one data set that is about soccer or football, depends where you live. I also have, let me think about, I don't remember. I have other data sets, probably with, I think I use in the book, sorry, but I have many models, and sometimes I don't remember if they're in the book or they're in PyMC examples or where. But I think another example that I use is this, I don't remember if I use the Boston house example or something similar, but I have a bike, one example from these bike sharing systems. And of course, in the book, because I think it's more introductory book, I try to keep examples relatively simple, even when they are real data sets. Usually they don't have, they are already clean, and they are already tidy, they are not very big, because the idea is just to introduce you to more to the models than how to deal with the data. But I also have a disclaimer at the first part of the book, the first chapter, saying that usually that's not what happens in in industry, and I think that's also a big difference. In industry, it's easier that you get much messy data, and usually when you work in academia, data tend to be a little bit clean, and the reason is that maybe in academia, not in all fields, but in some fields, you are the one generating the data. So you are running an experiment, or you are doing some observations. So you try to generate data as clean as possible, as tidy as possible. But of course, in industry, many times you use data that has been generated for other purposes. So you want to create a model to improve sales, then you get data from the marketing department. And the marketing department didn't create the data for you. They just create the data to have some record. So you need to put a little bit more effort there.
So based on the examples in the book, there could be a lot of cross-learning that people can apply in the industry, right? Am I right in saying that?
Yeah, as I say, I think there are many models that are very easy to translate from one domain to other. Of course, there are things that are common in one domain, but the thing is that again, for instance, biologists may be interested in some survival analysis or sensory analysis, and then you can translate that and say, okay, I have something similar for my clients because I'm not able to. If I want to tell you, you're my boss, and I want to tell you how much money I'm going to make for a client. I have an issue because there are clients that are still clients. It's not that they were clients for a period of time. So, okay, and that's the same that you can find in many problems in ecology. So the models can be translated from one place to the other. And actually that's, of course, not always is easy, but that's also a good source of modeling ideas, just to take a look at what others are doing, not just your domain, but what people are doing in other domains. Because probably they have already solved the idea, or at least they can provide a very good starting point.
That's a good way of looking at it. Thank you so much for that, Osvaldo. And I think look at this six also liked your answer. They've commented this on saying that it was a great answer. Thanks.
Thank you.
Uh, there is another query from on YouTube from Darnell. Osvaldo, how would you use the train your model notion to your data concept with synthetic data? Example, survey responses in a geographic area. Thanks in advance.
Okay, so that how would you use the train your model notion to your data concept with synthetic data? I'm not sure I understanding the question.
Darnell, if you could just clarify what your question is, or probably type it in again, we will pick it up and we'll discuss this for sure. I think yeah, even I don't understand what the question is exactly. Yes, you have he's commented again. They've said, yes, you have a set of real responses.
Again, I see, usually you will have a set of real data for every problem. But maybe what I was saying earlier is
And you want to predict how many more people in said area will respond and how. So it's basically prediction of basically taking a sample size data and the set number of responses. So Darnell wants to predict that how many more people would say have similar
yeah.
responses.
Yeah, the good thing about Bayesian models is they are generative, and the moment you write a model, you can sample from the model. So if you have a model, and you can immediately make predictions. And actually, one cool idea with Bayesian models is that you can make predictions. Let's say that you create a model. You don't want to condition on the observations. So you don't want to let your model know that you have observed data. You can sample from that model. And we call that prior predictive distribution or prior predictive sampling. So you can easily see what your model is thinking the data looks like. And then you can use that to actually improve your model. It's common that you generate a model and you obtain a lot of nonsensical answers because your priors are too wide, or maybe sometimes because your likelihood is not the most adequate. And the good thing is that you can, because you are generating synthetic data, you are not thinking about the parameters in your model, you are thinking about the synthetic observations. So things you could have observed. That's one idea, this prior predictive sampling, prior predictive check. The other idea is that once you fit the model to your data, okay, you can generate this posterior predictive. And once you have these posterior predictive samples, you can do at least two things. One is to compare to your already fit data, and in that way you can check your model if you think it's adequate enough. And the other thing is just use that data as predictions. Okay, so if you want to have this survey response and you get prediction from the model, you will get an idea of what to expect if you go again and answer the questions again, or at least if you answer in a similar population. Okay, and actually, if you go a little bit more complex with your model, you can create these hierarchical models where you have different groups, and that can be also useful to make predictions, because you can make predictions at the group level. So what a group with these characteristics what are the answers that I'm going to get from a group with this characteristic? But also you can have this idea of, okay, if I have a new group of people, that a new group that I have not observed, given my model and my data, what should I expect? But that's it. You just need to generate samples from your model.
Thank you so much for that, Osvaldo. Daniel has already responded on YouTube saying thank you both for your kindness and response. Always a pleasure, Daniel. If you have more queries, feel free to pop them in. In the meantime, let's do one thing, Osvaldo. Let's do our first raffle. I can see that there are a lot of people who've entered. There are about 10 people who've entered the raffle. So let's do our first raffle now, and then we'll do one at the end. I'll just share my screen.
Okay.
You can let me know if you can see it. There it is. I can
Okay.
see. All right.
Do.
Okay, let's draw the first one.
Whoa,
Let's see who is. Oh yeah, yeah. So that's exactly what it happens.
that's nice.
It's a
It's
draw.
not a. No, I say it's not a drum roll, but it's nice. Oh.
Yeah, like we can give it a drum roll. So, but yeah, it's too late. Congratulations, Cafe Babe. Uh, Whoever you are, I can see that you're on YouTube. Congratulations, you're one of our first winners for the giveaway today. If you are seeing this live, please contact me on LinkedIn. I'm pretty easy to find. Uh, Tushar Gupta, if you just type it on LinkedIn and if you add packed ahead of it, you'll be able to find me on LinkedIn very easily. Uh, yeah, you add me up and just share your name and email address. I'll get the ebook shared with you. Uh, Congratulations. And there is another raffle. Don't be disheartened for the rest of the people whose name wasn't picked up. We'll do another raffle towards the end of it. Please continue commenting hashtag packed as it says at the bottom on the ticker. So, Oswaldo, we'll move ahead and I have more queries. So, I confirmed with you about the Bayesian model for specific problem. Let's move on. I didn't ask you about tuning. So, what strategies do you recommend for selecting and tuning priors in Bayesian models?
That's another big one.
Oh,
Uh,
I have big questions for
You
you.
have big questions, yes. No, I think it's a big one because I think it's kind of unresolved issue. I mean, we have much better tools to create models on sample from models like in PyMC or analyze models like with ArviZ, but we still don't have very good tools to define priors.
Mhm.
Actually, I have a paper in collaboration with a lot of many authors that we try to provide like a kind of review of the state of the art of prior elicitation. We have also discussed some things that we would like to see in tools for prior elicitation. Now with others, we start actually trying to encode that into a library. It's called Prelis. We discuss that in the book. It's still very early, but you can already go there to Prelis and get some tools for doing prior elicitation. And we have some tools, for instance, if you have one parameter, it's common that you have one parameter and you know that, for instance, 90%, you know you want a gamma distribution and you know that 90% of the gamma distribution should be between 1 or 10 or something like that. So which is the gamma distribution that satisfies this answer? And the question is that there are many. So we add one more restrictions that we want the maximum entropy distribution. So we want the flatter possible distributions, the distribution with less information, the distribution with more uncertainty if you want, that satisfies your condition. So that's something that you can already go there to Prelis and call the maxed_n function, and it's going to solve that issue for that. But of course, that's only work for one parameter, and usually models have a lot of parameters. So
Yeah.
in general, I mean, that's good when there are many models when you have many parameters, but you really care about a few. So it makes sense to use that kind of tool to actually be sure that you are taking care of the parameters that you really want, that you really care. But still, if you have something that is very large or some model that you're not very familiar, how the parameters relate to data, the other thing that you can do, again, is sample from your model. Okay?
Mhm.
So I don't have, I put some priors there, and I don't have any idea what these priors are doing, what they are affecting my results. Okay, sample from your model. And again, we call that, if you are sampling just from the prior, we call that prior predictive sample, prior predictive check, etc. So you sample from the model, and you can compare to your domain knowledge. I suggest in general that you don't compare your samples from the prior predictive distribution to your observed data, because you might be leaking information from the data into the prior, and that's the job of Bayes theorem, not you. But try to compare to the domain knowledge. So again, think about your data. Think about the population of the data generating mechanism, and think how the data that you have not observed yet may look like, and try to fit that. Again, this is a very powerful tool, but sometimes it's not that easy because you have to fit a model, you have to generate the samples, you have to do some plots, then you have to go back to the model, tweak some parameter, and iterate. And that is sometimes that may be too time consuming. And when you see that something you don't like in the prior predictive distribution, you have to know what to change on prior to get the result that you want. And for a complex model or a model that you're not familiar, probably you are not going to really know what to change, or you may change something and get unexpected results. So that may be good because that can help you understand your model, but again, can be time consuming. So we are also in Prelis adding some tools that try to make this process a little bit more automatic. So for instance, that you can create a model and you can use sliders or boxes to change values, and immediately you get the change in your synthetic data. Or actually models that you can provide is, okay, I think my data that I have not seen yet should look like this. Can you provide me a good prior for this? And again, for all these tools, the idea is to keep the human in the loop. So you are still the one that is accountable of making the model decisions, but we are trying to provide some tools to help you to make this process, to keep some iterative aspects of the process, because we think are beneficial, but at the same time to make possible that you iterate faster. And when you iterate faster, you focus on the things that matter, and not on computational details or that kind of thing. So the short message is you can go and check Prelis, or simply, again, sample from your prior.
So how can how can one ensure that the priors are informative and yet not overtly influential?
Well, one tool you can use is, again, sample from the prior predictive, and see that you are not getting. Let's say that we have a very simple model for temperature. Okay, if you temperatures on Earth, on surface of Earth, if you are sampling from that model and you get temperatures that are over 100 Celsius, your model is probably doing something wrong. Okay.
Yeah.
Probably that's not that problematic if you have enough data, because the data is going to be able to concentrate around reasonable region. But still, maybe you can improve and say, okay, maybe temperature above, I don't know, 50 degrees is already something unlikely, at least for now, it's relatively unlikely. So you want to tune your prior to be a little bit more constrained. Or it could happen the opposite. It could happen that you think that you put a prior that is vague enough, or convey the information that you think are conveying. And when you sample from the prior predictive distribution, you realize that you have all your temperatures are around, I don't know, they're all between 24 and 26 degrees. Okay, so probably you are putting too much, unless you have a very, very good reason to think that temperatures should be in that very narrow region. Probably you are doing something wrong. And again, we are, there is a recent paper, relatively recent, that tries to put this in a little bit more automatic way, that essentially you provide a model, and what this idea and there is a software package, now it's on ARC, but we are implementing the functionality in ArviZ. So part of that functionality is already in ArviZ, but probably in the next month or a couple of weeks, we're going to have more functionality to do that. That tries to kind of automatize this a little bit. And internally, what it's doing is you are providing a model, and internally, in a clever way, is tweaking. It's like if you created not only your model, but a model with wider priors and a model with narrow priors. This is all automatically and relatively fast. It's not that you don't need to refit your model. You just provide one model, and internally it's doing some clever tricks to do that, and it's providing you with a very simple summary that is telling you, okay, this prior is probably too influential. And the interesting thing is that it's also providing the same information for the likelihood. Because it's, I understand that for newcomers, usually they are super worried about the priors, but not too much worried about the likelihood. And sometimes you need to be worried about both, or you need to think about both as a single entity, because of this idea that you can only understand your priors in the light of your likelihood, or vice versa. So this tool is also providing you with information of there is if your likelihood is influential, is your likelihood influential or not influential? Is your prior influential or not influential? And again, then you can make a decision, because maybe the prior is influential, but you want it to be influential, so that's okay. But this is going to warn you. Be careful that this prior is very influential, and maybe this likelihood is not influential. That's like the worst case, because almost everything, or almost all the information is coming from the prior. Sometimes that's the case. Sometimes you want this, not in general. But anyway, the point is that we have part of this tooling implemented already in ArviZ. And as I say, probably the next release of ArviZ is going to have the full package with plots and everything super easy to understand. And we are going to create 1 or 2 examples so everyone can see how to interpret these results for their model.
Brilliant. I actually missed out on a question earlier from LinkedIn. Ronald inquires that, what do you recommend for the book to read after this book? Before you answer that, I think there is an assumption over there, because you mentioned that it's an introductory level book. Firstly, can experienced people or people who are already practicing Bayesian analysis learn more from your book? One is that, and then secondly, after they complete the book, what do they go to next, or what do they do next?
Yeah, I mean, I think you can read the book, my book, even if you don't understand anything about the statistics. It can be your first statistical book. Of course, if you already have some notion of statistics, it's going to be easier. If you already know what a mean is, what a variance is, or what inference is, or why we fit models in statistics, it's going to be easier. But even if you have a very vague idea of just, I don't know, statistics is this thing that we do to analyze data, I think you can already benefit from that. If you are very experienced in Bayesian statistics, probably the book is going to be a little bit boring to you, unless you want to, you know Bayesian statistics, but you're not very familiar with the Python ecosystem, so you're not very familiar with PyMC, ArviZ, and the other tools. So in that case, you can also benefit from the book, because there are a lot of examples of how to use these tools. So you get some benefit from there. What to read after? There is a chapter at the end of the book, chapter 11, that I provide some guidance of what you should read. One book that I really, really recommend to everyone is Statistical Rethinking. I think that's a very good book to read. Probably that's a book that it's this kind of book that if you are analyzing data, you probably should read it. There are 2 editions of that book. Actually, I recommend that if you have the time, you read both, because the second edition is more close to, it has this idea of causal inference all over the book, even if he's not doing, even if for some problem he's not doing causal inference, he has this idea of, okay, you should be careful about how you approach a problem because maybe you have missing variables or that kind of element. But I know that for some people that can be like, okay, maybe too much because you're mixing like two ideas. So maybe you can take a look also at the first edition. That is a little bit more classical in the sense that it goes from a problem and how I use a model to solve this problem. And the book is written in R, not Python. But many, including myself, have translated part of that code to Python and PyMC. And actually, if you go to PyMC repository, you're going to see there that is the complete set of examples there, so you can use it and run it. And I think it's a very good complement. And it can go both ways. Even if you have read statistical rethinking, I mean, it's not that one after the other, but probably the both together. I think they complement, they cover different aspects. For example, in statistical rethinking, there is some discussion of Gaussian processes, but it's taking a different perspective than the one I use in the book. So you benefit from getting both perspectives. And actually, there is one example that Richard, the author of statistical rethinking, allowed me to use. And there is one example that I take it from that book, I tweak it a little bit, I make some arrangements. So it's not exactly the same example, but it's similar.
Okay. There is a first comment on Twitter.
Sorry.
Oh, sorry, go on.
One more book that I think is very good, and also because it's enriching because it's writing from a kind of different perspective. Is a regression and other stories from Aki Vetteri, Andrew Gelman, and Jessica Hock, if I don't. Oh, yes, I think there are three authors. Regression and other stories. And that's a book that goes very well with, because the way they write, they have read the book, is a book that goes very well with Bambi. That is a library that we discussed in the book. So probably if you go and read that book, you can almost automatically, even if again the book is in R, you can go and implement the examples with Bambi.
Okay. Thank you so much for that, Osvaldo. Okay, I'll just come back to this quickly. So Neil Lambert on X, not Twitter, sorry, on X, inquired, will there be a recorded link for this session to be able to rewatch? Neil, I'm not sure if you follow Osvaldo, but Osvaldo posted, he tweeted about it yesterday. There's a link to YouTube. That's where the recorded link will be. So if you can just go on, I think you're watching it on Osvaldo's X page right now. So I'm sure you do follow him. So in case you do, just have a look at that. If not, just DM Osvaldo about it and he'll share the link with you. Because I'm not really sure where you're watching.
Sorry, I sorry about that. I feel very bad. Jennifer Hill is the name of the other author of Regression and Other Stories.
The other author that you were talking about.
Sorry.
Ronald has actually commented and says that the book that you're talking about, he loves that book and it's free too.
Yes.
Great. So, perfect, Ronald. I'm really happy that you're satisfied with the response. Neil, if you can just comment and let us know if you're satisfied with the response about the YouTube recording link. If not, please just comment about it so one of us can reach out to you on Twitter and then just sort this out for you. X, not Twitter. My bad. I have one last question for you, and given that we are short of time now, let's wrap up on this question and then we'll do a final draw. How can people improve the computational efficiency of Bayesian analysis for larger data sets or complex models?
Yes. One thing that you can do as a user is many times is, again, think a little bit better about your problem, because many times You can improve the sampling efficiency by setting better priors or by writing the model in a slightly different way. So sometimes this is relatively easy. Sometimes this is something that you by iteratively checking your model, you are going to find that you can improve it. Others can be a little bit more difficult because it's based on trying to reparameterize models or write the model in a different way. A classical example of this is hierarchical models that have this center and non-center form of writing. It's like two versions. And so the results are exactly the same, but you write the model in two different ways. Depending on your data, one way is more efficient than the other. So sometimes you just need to check. So that's the kind of thing that you can do. Or sometimes there are things that are relatively easy, like centering data for linear regression. That usually helps. And it helps with the model, and it could help with the interpretation of the parameters also. And then there are moments that you are not going to have any idea of what to do. So you need to rely on others, and hopefully there are a lot of people trying to make Bayesian models run faster. And actually, one of the change in PyMC, the last version of PyMC, is that now we have this new backend, PyTensor, the name of the library, and PyTensor tries to be very clever, try to do a couple of things. One thing is that you can think of PyTensor as like kind of compiler for models. So there is people working with PyTensor trying to make this compilation thing more efficient. So automatically notice that your model has something and try to rewrite it in a more efficient way. So that's something that you are not going to even, you don't need to do anything, just install the last version of PyMC and you are getting this efficiency rewrites for free. And that's something that is continually done. So if you install the last version or in a couple of weeks, you probably are going to see some benefits. And also one thing that PyTensor allows is that compiles the model. We all know that Python can be slow for very intensive applications. So if you need speed, you need to trust on languages like C or Rust, or you need to use tools like Numba, or NumPy, things like that, to speed up your code. And PyTensor can compile to JAX, can compile to C, can compile to Numba. So you get this improvement. And for instance, now we have, there is a new sampler that I also briefly discussed in the book. It's called NumPy. It was created by one of the PyMC developers. The sampler is faster for two reasons. One is because it's writing in Rust. And the other is because Adrian, the author, was thinking a lot about how to improve some internals of the sampling algorithms, and he came up with an idea to make the algorithm more efficient. So you can already go and use that. If you have the one of the last version of PyMC, you can call this NumPy sampler, and you are going to get, I don't know, 10, 20, sometimes 10 or 20 times faster just by changing one line. And of course, there's a lot of research. There's a lot of research and people trying to take advantage of GPUs and probably TPUs on new hardware that is available. So there's a lot of research on samplers that can sample a lot of change at the same time. And that could provide speed ups. So at this point is, the short version, again, summarizing is, if you are seeing some bottleneck, try to use this new sampler like NumPy that you can directly use from PyMC. There is you also have access to other samplers from Blackjack, that is a library of samplers, or NumPy, etc. And the other thing is that maybe you can try to tweak your model a little bit. And well, and the other, there's another option that maybe you can go to, you can move away from Markov chain Monte Carlo, from MCMC methods, and try to use some other approximations. I know there's a lot of people using variational inference that is way faster. And you have to be a little bit extra careful with variational inference compared with MCMC. It's like completely different beast. But for many problems, you can get good results, or at least good approximations to, and that can scale to large models or large data sets.
Perfect. Thank you, Osvaldo. Neil has responded on on X over here. Neil, if you're still watching, what I've done is, while Osvaldo was answering this final query, I've gone on to his X post and I've tagged you in there. So you would receive a notification where he shared the YouTube link yesterday. Yep. You can find the YouTube link over there simply. You don't have to go and search it. So I hope that helps. And with that note, let's do our final raffle. And here is the final raffle. Our first winner was Cafe Babe on YouTube. So yeah, whoever you are, please contact me on LinkedIn. And let's do our final raffle over here. All the best, everyone. And here it is. You want a drum roll, right?
Yes.
I'm doing a fake drum roll. And there is someone called Savitri Baka. So yes, whoever you are, please reach out to me on LinkedIn. Again, the same. Please share your name, email address, and I will get the book sorted for you. On that note, Osvaldo, do you want to share any closing notes? And then we can end this live stream.
I just want to say that if people watching, hearing us have some questions, or you can post those questions. If they are related to the book, there is a GitHub repository. You can post questions there, open issues. If you find mistakes, we try to reduce the number of mistakes as much as possible, but there's always going to be some mistake. So please open an issue there, and we can try to solve it. And if you have a more general question about PyMC or any other of the tools that we discussed in the book, there is a Discord channel for PyMC. So please, people, go there and ask questions. And if you are interested in participating in open source development, but you feel afraid, or you feel that you are not able to do it, I recommend that you go and again reach one of these libraries: Bambi, PyMC, ArviZ, Prelis, Culprit, PyMC bar, whatever, or the library that you want, and start reading documentations. And start. You can maybe start. A lot of us started fixing just a comma, or I don't know, some simple example in the documentation, and from there we start contributing more and more and implementing the things that we actually need, or the things that we realize others need. Usually it's a very welcome environment, and at least for me, contributing to the open source has been one of the most fulfilling experience, probably followed by writing books about Bayesian statistics.
Perfect. Thank you so much, Osvaldo. And thank you, everyone, for joining today. I hope you enjoyed the session. I'll have a new one streaming and announced pretty soon. I'll see you all in that event. Thank you so much for your time. I'll see you backstage, Osvaldo.
Okay.
Thank you, everyone. Bye.
Bye-bye.